In this lesson, we're going to try and consolidate our knowledge about linear relations, really concentrate on those equations, build them from a variety of situations, tables, words, graphs, and then maybe do some working with them a little bit. Okay, so our big ideas from this unit so far is there's this pattern, it makes a line, if we graph it, we call those linear relations. They usually take the form y equals b plus mx, or vice versa, mx plus b. Order is not important. We've said that throughout algebra. Letters are, we have to tell what they stand for. Numbers are, signs are, orders not. Some big reminders, B is called our initial value, or the fixed amount, or the flat fee. On a graph, it's the vertical intercept. By that means this is my vertical line. Here's where I start. We call it the vertical intercept. Later on in the course, you might see some things called, it's the C-intercept, because we're talking about C for cost. Okay, that's your vertical line. M is our rate of change. We did this one yesterday. Or slope, or gradient, and can be found by our formula. And we haven't really been too specific with this formula yet, but y number 2 minus y number 1, where that's coming from is typically, when you talk about the vertical axis, that's your y value. So I said in the previous lesson, take your second y, that's your height, and minus your first y, and divide it by your second x minus your first x. And we'll do that in a little bit here to practice that formula, but really the big idea is the difference between 2 points. Okay. X and y are 2 variables. You don't have to use x and y. It's your choice. It could be c and n. It could be m and b. It doesn't make a difference. Typically, we just use x and y because when we start graphing, we have an x-axis and a y-axis. X is the one that goes left, right, and y is the one that goes up, down. Okay. We always write y equals because y is my dependent variable. It depends on the x value we choose. It's the output that depends on your input. Okay, that's a lot of big ideas. We're just going to practice with those today, as I said. Let's start with this one about 2 different school field trips. And we have 2 trips. They're shown 2 graphs. We got a selection of questions here to answer. They are, in the first one here, on one of the trips, there's an extra cost to pay for the teacher. Which trip is it? Which trip has a different initial cost? Well, we can see this graph starts at 0, but this graph starts at 10. So I think graph B has a extra cost. It has an initial value of 10. It's a partial variation, as we've talked about. Which trip costs more per student? Well, if I see that word per, I'm thinking about the word rate. So let's find the rates of these things. Okay, on a graph, this one starts at 0. I can actually see at 1 student, it costs me $10. So this one's going up at $10 per student. On the other graph, we started at 10. 1 student's here, now it's up to 15. Well, that's $5 per student. And I want to point out, remember, it's the rate of change. How much has it changed? It went from 0 and 10 to 1 and 15. So it's gone up $5. Common mistake there. People say, it's $15 a student. Well, no, it's not. It started at 10. So it's gone up $5 a student. So which one costs more? Graph A has the higher rate. Okay, what are the independent and dependent variables? Well, my cost depends on the number of students. So my 2 variables are students and cost. Cost depends on, so cost is my dependent, and my number of students would be my independent. If you think of it as a sentence or a phrase, my cost depends on students, well, that tells you which one is dependent. Write an equation to represent each one. We can do that. So I'm going to do graph A first, and then we'll do graph B over here. And the cost is, C stands for cost. The first one starts at, it started at 0. You can see on the graph. And it was going up at a rate of $10 a student. So I'm going to say plus 10n. N is my number of students. Now that equation is beautiful, but you could make it easier if you want to. You could just say 10n. There is no initial value. You don't need the 0 in there. The other one started at, well, we look at our initial value in the graph, it was started at 10. It was going about $5 a student. So 10 plus 5n. I don't need to redefine my variables because I already did them over here. They use the same letters. Okay, which graph shows a partial? Which one shows a direct? Well, we can figure that out pretty easily. Which one had an initial value? This one did. So that one is partial. This one had no initial value, had a 0, so this one must be direct. Okay. Every student's $10. It goes up 10 every single time. The other one had that initial value of $10, so I can't just multiply by the number of students. Okay, kind of our typical question. We're going to get you guys to try some now. Okay, so pause, you try, do as many as you can. We'll keep coming back and forth. We'll try these together. Today's just practicing. The graph on the right shows the height of a hot air balloon changing with time. What is the balloon's initial height? Well, that's an easy one. Where does the graph start? 250, and those are meters. What does point A show? Point A, which is right here, shows me that when I get to 3 minutes, I'm at a height of 220. At 3 minutes, the balloon is at 220 meters. How fast is the balloon sinking? Fast. That reminds me of rate. To find rate, I'm going to find the difference between 2 points. So, nice point for sure. At 0, we are at 250 meters. Super nice point A, we just did that one. At 3 minutes, it was a height of 220 meters. So our formula says take the second value, which is 220. That's my y value, the second number, minus the first one. Okay, so going back to the beginning, technically x and y. So this is y number 2. This would be y number 1. X number 2. X number 1. That's how our formula works. We just talked about in terms of the difference between 2 points. But technically, this is what you should be doing. Okay, let's do some subtracting. We get negative 30 on the top, and those are meters. On the bottom, we get 3, and those are minutes. And if we divide that to get a rate, we get negative 10 meters per minute. Write an equation for the graph. Oh, okay, what do we got here? We got height. H for height. It was 250 to start. It's going down at 10 meters per minute. I'll tell you what the letters stand for. H is my height, and M is my number of minutes. Hopefully you guys are okay with that one. Kind of a typical graph. Okay, let's do one more of those just to make sure. Okay, if you didn't try the second one, try this one yourself. Pause it, check your answers. The gym charges a membership fee for students and a cost per visit. Write an equation. So put it all together here. Okay, let's make an equation. C equals, let's see, C is my cost. What do I pay right off the bat? Well, I can see from the graph, it's $15 right off the bat, my initial value. And a cost per visit. Well, one visit would be right here, so now it's going to cost me $20. So I was at 15. After one visit, I'm up to 20. So I've gone up $5 per visit. V is my number of visits. And we're done. There's our equation. Okay. If you didn't like the way I found my rate, we could also do our formula way. Our rate is 20 minus 15 and 1 minus 0. Or in other words, 5 over 1, which is $5 per visit. If you don't like that way, you could always go to the table. These are all interchangeable ways of doing things. Visits, cost, 0 visits, $15. 1 visit, $20. It went up 5 per 1 visit, which is the same math we see right there. Right, graphs aren't too bad as long as you can find some nice points on them. Let's move to tables. We got Julia. She's known for taking long, hot showers that leave the rest of her family waiting, probably like some of you guys. They decide to study the amount of water she is using, and they've come up with this table. So what are our questions here? Is this relation partial or direct? Well, let's look at what's happening at the beginning. At the beginning, she's used no water. That means it's a direct relationship. There is no initial value. When she steps into the shower, the water's not running yet. Part B says, how many liters per minute? Oh, there's that word again, per. This is a rate question. Now, I don't have a graph to read off of, so I'm going to use my table. The quick way in the table is the difference between 2 points. It went up 36 liters every 2 minutes. Well, let's divide that out, and we'll get our rate of 18 liters per minute. Hey, tables are nice, right? You don't have to worry about nice points. They gave them to you. Now, if you hadn't chosen those points, let's say you chose different points. Maybe you chose, I don't know, these two. You could do that. That's 126. And over here, 2 to 9 is 7. So she's using 126 liters every 7 minutes. Well, if you divide that out, shockingly enough, you get 18 liters per minute, which obviously is the same, which it should be. It's a linear relationship. All right, part C, write an equation. Okay, C, equation. What do we got? What are my units here? Oh, I got liters. L is, well, I don't have an initial value. I've got 0. And I'm going up 18 liters every minute. So I'm going to say L is my liters, M is my number of minutes. This equation's beautiful. A better equation might even be shorter, just that. It's a direct multiplier. Can we actually use this equation now? Sure. Part D says if Julia takes a shower for 15 minutes, how much water will she use? Well, her liters are 18 per minute. She's doing it for 15 minutes. This is just some multiplying now. And we get 270 liters. Okay, you guys are going to try one for me. The table below shows Mindy's pay at Vision Optical, where she earns an hourly wage plus a fixed amount each week to cover her expenses. What is her fixed amount? Well, a fixed amount is a fancy word of saying what's the initial value. So at 0, she's already earned some money. She's earned $150. Part B wants an hourly wage. An hourly wage means how much per hour. Well, that's a rate. We've got ourselves a table, so we'll find the difference between any 2 points. I think that goes up 120, and those are dollars per every 10 hours. Well, that means she's making $12 an hour. Write ourselves an equation. Sure, we can do that. My E, my earnings, E for earnings, is, well, what did she get for showing up? $150. And she got $12 every hour. H is my number of hours. And we got ourselves an equation. Let's use that equation. How much would she earn after 40 hours? Well, she automatically gets that 150, and she gets 12 for every hour, and she's working 40 hours. You can replace the H with 40. Do your bed math here, just to be careful, or use your calculator. Multiply first. She would earn $630. Okay, part E, she needs to earn $450. How long does she need to work for? Well, this time, I know the earnings. I'm going to replace the E value. So 450 equals 150 plus 12H. Well, this is an equation to solve. This is algebra again. Numbers on one side, letters on the other. Let's bring that 150 over. We'll simplify it. I don't want to know what 12 hours is. I want to divide out the 12 to know how many hours she actually needs to work. And if we divide that, I got 25 hours. Okay, now we're applying all of our skills, algebra skills, evaluating skills, simplifying. in addition to equations of lines. Okay, last one. Taking away the table, taking away the graph, just putting into words. A bowling alley has a fixed base cost and charges a per game rate. It costs $20.50 for 5 games and $28.50 for 9 games. Is the relation partial or direct? And how can we tell without having a graph or a table? Well, the words tell us. It tells us it has a fixed base cost. In other words, it has an initial value. That means it has to be partial because it has an initial value. Okay, let's write this information into table form. Make our life easier for ourselves. So in a table, my answer, my resultant, my dependent depends on what? Well, it depends on the number of games, what my cost is. So my information up here tells me it cost $20.50. So even though the number came first, it should go in the right column for 5 games. And 9 games was $28.50. Can we find the per game cost? In other words, can we find the rate? Well, of course we can. The difference between 2 points. It went up $8 every 4 games. If I divide that out, it's $2 per game. Part D, determine the fixed base cost. Okay, so here's where we're going to get a little fancy for a second. My cost is a fixed base cost. I don't know what it is, but I know it's $2 per game. So I said C is my cost, G is my gains. Okay, my B is my base cost. I don't know what that is. I'm going to figure it out. And here's how I'm going to do that. I'm going to take a pair of numbers that I know. Doesn't matter which one. I know this one. I know my cost is $28.50, and that's made up of my base cost plus 2 times the number of games, and there's 9 games. This is algebra. I can solve this. I get rid of my brackets. I rearrange, and I get my B value. My B value is 10.5. There's my base cost. Now, if you use a little common sense for a second, here's how else you can do it. I prefer the algebra way because we need to be able to do the algebra way. But the common sense way is, well, 5 games at $2 per game should cost, well, 5 times 2 makes 10. Oh, but I know it's $20.50. The difference between what I know it is and what it should be has to be the base cost. Okay, so if I find the difference between those things, $20.50, and I minus my 10, it comes out to the same answer. Okay? This is kind of the common sense way of doing it. I kind of want us to be able to do the algebra way because that's going to make our life easier down the road when we have to solve for more complicated things. But they're actually doing the same thing. If you look at it, we multiplied the 2 things together, 2 times the number of games, then we brought it over and subtracted it, and we got our base cost. We just did it with algebra instead of just doing it with common sense. Either way, you get a base cost of $10.50. All right, write an equation. This is why I like the way I did D with algebra. I already had most of my equation done. Okay? I had C for cost. My base was $10.50. It was $2 a game, and I'm done. I've already defined the letters up there. Okay, last part. How much does it cost for 12 games? Well, here's why we like the equation. My cost is $10.50 plus $2 for each game, and there's 12 of them. Do our bed mass. So we get 24, and we get $34.50 for those number of games. Okay, big lesson today. Not really new stuff, putting it all together stuff. Lots of skills involved. Hey, try the sheet off the website. If you're stuck, come see me, ask me some questions, and then we're going to move on to new stuff later on.